Thank you very much, Britta, for the introduction, and thank you to all participants of this really interesting afternoon session. In this introduction, I'm going quickly to present you the main concept supporting the realization of all the pilot measures that were realized within the LowTEMP project. So how was mentioned already this morning by the presentations of my colleagues Britta and Adam, the implementation of the selected pilot measure in order to evaluate the potential technical and economic feasibility towards the transition to low-temperature district heating was a real essential and important outcome of the LowTEMP project. Basically, this because was essential towards the identification of which were the barriers and bottlenecks that somehow create obstacle to such a transition. Use in this way, pilot activity were specifically made in cooperation with the municipality and the region involved in the project, in order to test and to start a real low-temperature district heating project in already existing district heating infrastructure. I would like to say that this task also was, as was also mentioned before by my colleague Lilian, was really essential for the finalization of the pilot energy strategy in terms of key steps for the precondition analysis within the developed overall methodology for making low-temperature district heating strategy. The scope of the pilot was basically addressed to explore different type of background conditions and potential application of different type of technological solution based on which were the main needs that were identified for each municipality in terms of type of existing district heating supply infrastructure, type of connected building, and potential improvement solution. This was essential to give the possibility to apply in already existing building context somehow the initial background to move to a maybe larger low-temperature district heating supply in the Baltic Sea region. As a last point, the activity was also addressed to include and to present the efficiency and the effectiveness of new install monitoring system as a precondition for the transformation to a low-temperature district heating. So after this really main introduction about the background that lead to the selection of the pilot, here I just describe which were the planned output according to the project development. First of all was, of course, to perform the pilot project within real pilot activities to develop real low-temp potential real project. These activities were, of course, a sort of supplement and support for the development, as mentioned, of the pilot energy strategies. And the second main big effect was, of course, to use such activity to raise awareness on how to process and how to move forward to make a real action in order to improve district heating system and how this should looks like. In this way, the output were favorable as well in terms of behavioral changes addressed to reluctant attitude of municipality, investors, or other type of utility operators. So before giving the words to the specific pilot case study of Halmstad, I would like here to make just a quick list of which were the pilot measure implemented. They were really wide and with different scopuses. They were implemented in 7 regions with a total amount of 10 described and reported pilot measures. In Denmark, we had a feasibility study and design for possible implementation of district heating system in the local district heating network of Morkov. Ilmajoki was already presented in the pilot energy strategy, and the pilot was the use of waste heat from the pilot plan of Kosken Korval for vodka production. In Tartu, we have as well a feasibility study and implement a strategy to understand how we can implement a low temperature district heating solution in Karlova district. In Alux, in Latvia, in Vidzeme planning, in Vidzeme region, we have a study about how to properly create a monitoring system for as a precondition for future low temperature district heating system, and this in specific the attention was addressed to a kindergarten. For Gulbene, we had the case study of the first low temperature district heating realized in Latvia in Beljava village in the municipality of Gulbene. We had also a Russian partner that really made a really important pilot on precondition analysis in different buildings and possible design for reconstruction and modernization of heat substation potentially capable further on to accept a low temperature district heating system. In Poland, we had 2 real good pilot measure. Once related to the modernization of a gas boiler in Rumia, and the second about the installation of the installation of a novel system for potentially lowering the operating temperature parameters. And then we have a small introduction, the latest pilot that we presented later about how low temperature district heating can be implemented in a new residential area. And we will see as well how was practically implemented a study on how to determine properly the pipes outer casing accepting the low temperature district heating condition. So this is the end of my presentation. That should be considered as introduction, of course, for the real interesting pilot measure in Halmstad municipality. Thank you all for your attention.
Thank you, Francesco. And from Riga, we shift to Sweden, to Halmstad. Rolf and Patrick, are you there?
Yes.
We are here.
Hello, welcome. The virtual floor is yours.
Thank you. Thank you. I will share my screen. So I hope you guys see this.
Yes, perfect.
I'm going to talk to you a little bit about a new residential area being built in Halmstad in Sweden. The municipality of Halmstad have had some goals to be in the front line regarding energy efficient new areas. And my company is Halmstad Energy and Environment. We are owned by the municipality, and we were asked to collaborate with a university that are world leading in the science of district heating and the research of district heating. And we also were asked to share the knowledge that we have with interested parties and other cities around us. In a few years back, there was a new residential area planned. There are around 500 houses and apartments in this area, and we saw this as a big opportunity to test out the new low temperature district heating network. And also the University of Halmstad had researched about the third pipe in this low district heating. So we call that the fourth generation 3P, the third pipe. And this area is going to be a great testing ability to see the efficiency of this third pipe. So we divided this area into 3 main areas. The phase 1, as you see, is the one where we will try to use this 3-pipe solution, and the phase 2 and the other one in the right, we're going to try the 2-pipe low temperature district heating. So this third pipe system allows the return temperature to be lower, theoretically. So we wanted to test this out if this is true. Why is it's so important to have lower return temperature? The lower the return temperature, the better our facilities work. So we can be more energy efficient, and we have less losses, energy losses in the network. And this third pipe circulates the heat water, instead of leaking it to the return pipe as the standard in all the district heating networks. We circulate that heat, so the temperature in every customer's house is the same as in the network, without having to circulate the hot water back into the return pipe and higher the temperature in the return pipe. So we are aiming to decrease the temperature in the return pipe from 32 degrees to 28 degrees. That's our goal. Theoretically, that's the case, and we're now going to see how it is in reality. When we are talking about low temperature, we are talking about 65 degrees. In the rest of our network, we have around 98 degrees. So what were the challenges here we saw? One is, where should we place this third pipe? Because with every house, we need to make this service line from the line in the streets, from the network in the street into the house. So we're going to go strictly to the side. And to do that with 3 pipes is a bit difficult, because you also need to go up and down sometimes. And there are no ready-made pipes with 3 pipes with isolation. So we need to place this third pipe somewhere. And this third circulating pipe is a little smaller pipe. So we did some calculations on the placement, and you can see that in the lower right corner, how we decided. But to be sure that this actually worked, we decided to make some tests, welding tests. Can we build this way. And here you see in the middle where they're welding these service lines onto the main pipe. And we realized that we actually did need a little bit more space for everything to work. With this welding test we did in the quite early, we realized that we had to recalculate the whole area to make the pipes fit. With this very small and very low cost test, we managed to decrease or lower the total cost of this whole project, because if we had found this out while we put the pipes in the ground for real, it would have cost us quite a lot of money to displace pipes to be able to fit them all. And I said that we are going down from 98 degrees to 65 degrees. We are doing this with a downshift station or a shunt station. So we have pumps working. So we use some of the hot water in the main pipe outside and use the return water from this area to mix and get down to 65 degrees. So around 50% of the return water is mixed with the supply water to obtain the desired temperature. And these valves in this building is regulating the temperature. So we see that we get the right temperature. And then the rest of the water goes back into the main pipes and lower the temperature of the whole network. And right now we are looking at this. This is a building of the site right now that we're building. So we're on the way to building this. The pilot testing was the calculation and the design and the testing beforehand to see that we made this the right way and got the results we wanted. And the main components in this downshift station is the distribution pumps to get the water flowing in the network. And each pump are dimensioned to handle the total flow. So we are backed up because this is a very important part of the network. So we can't have the system going down while servicing one of the pumps, so on. And we have control valves to control the water mix, so to get the desired temperatures. We have bypass valves because this is new technology. We want to be sure that our customers do have the heat needed in this area. So a few years back when we started this project, we decided that we should design all this network to be able to run on high temperature if needed, because we are trying to pressure push the temperature down in the network. And if this doesn't work, our company wanted to be sure to give our customers right temperature in their houses. So we put in some bypass valves. So if we don't see this technology working as we have designed, you can just raise the temperature so the customers get the temperature they need. Our goal is to have this as seamless as possible, so our customers, the people living in the houses, should not notice anything that this is new technology in this area. We're also monitoring and controlling the whole networks, seeing the temperatures on different places in the networks. so it can regulate the temperature with high precision. And we have secured high availability with this design. And with this, I give the word to my partner, Patrick, here. Welcome.
Oh, thank you. Good speaking, Rolf. Our work, as Rolf has talked about, is important. It's important to do the tests and the real construction. It's not a drawing; it's real pipe in the real life, and it's very, very nice to see that we are building what we have been planning for a long time and having a great project for. So. As Rolf has talked about, the advantage with the three-pipe system, the test of it and the building of it, handling with the construction, so we actually is able to put a low-temperature district heating grid within a high-temperature district heating grid, and being able to choose whether it is good or bad. We are monitoring, we are seeing if it's working, and if it's not, we can choose to change it back. But we are certain that it will show us what we are expecting to see: less energy losses and better economy for the customers. It's important to make it work in general. It's technique, of course, but it's we need to put it in a bigger perspective, in a society planning, a city planning perspective. And if Rolf is changing the picture, we have more goals. We have to look forward to the Titan battles, to have a dialogue with the house manufacturers. It's quite normal, quite common that you include cheap, energy efficient, yes, heat pumps in the houses, in the buildings. But if we are supposed to compete with the district heating, we need to have a good dialogue. So we have the infrastructure in place. It's not necessary to put cheap heat pumps that are actually consuming electricity when you have the opportunity to use surplus energy, waste heat in a district heating grid. So that is a dialogue we need to have, and I hope we can be as successful in that as we have been in the construction of the new area. And further, of course, the business model, a lot of people have talked about it, but we need to make sure we make money, we make business, and we make a city development in and with this technique, and use wisely of our resources. We need to downsize in the use of resources overall, but we need to upsize in reuse, in less energy consumption, and of course in better techniques. So overall, we need to do the packages to develop proposals. So it's a good idea to sell surplus energy, to use the grid, to communicate all the advantages with district heating, and of course using waste energy as we do in Halmstad, as at many places, and put it together in the sales plan for Arnegård. And the last picture, Rolf. Can we have the last picture? Oh, I got a message. His presentation doesn't work, so I changed to mine.
Okay, thank you. Last slide, yeah.
Last slide. Excuse me for that.
As always. The last slide.
The next. Well, as I've been spoken about, the next step in our work is to proceed with all the buildings, to see the infrastructure be ready and to see all the houses being built. As Rolf has talked about, it have been various constructions, single-family houses and multi-family houses. And I hope we will end up in a good new area for Halmstad as a part of Halmstad city planning for the future. It's a small step for district heating, but it's actually a giant step for a small city as Halmstad to use new technique, to develop new technique, to be a part of a greater project, European project, and even lead the work and the construction all the way to the fact that we are moving into new houses with this technique. So that was actually all for us. And well, if you have any questions, just give us an email, and why not pop up to Sweden and Halmstad and just look at it. It's as long as you have a big excavator, you can see the pipes.